So we are on perpendicular and angle bisectors. First, we'll talk about the perpendicular bisector theorem. This is a point right here on the perpendicular bisector. This is my perpendicular bisector right here. And notice it is perpendicular and it cuts a segment AB in half. Okay, so this says that a point on the perpendicular bisector of a segment is equidistant to or from the endpoints of the segment. So it's talking about this distance right here. This distance from the point on the bisector to the endpoints. These are going to be congruent. These are congruent. Okay. So now we go to the converse. The converse says if a point is equidistant, or is equal distant distance from ends of a segment then the point is on the perpendicular bisector. Okay, so it's the converse of our perpendicular bisector. So this says basically, well, if my point right here, let's say if my point is equidistant to the ends again of my segment, then the point must be on the perpendicular bisector. Okay. So let's go look at our examples. Example 2 says, well, let's look at this. We have a segment OY, okay, and then we have this line ST right here. Notice that ST bisects OY, and it's also perpendicular. Okay, so ST must be a perpendicular bisector. Now, if it's a perpendicular bisector, that means our sides, or the distance from OT and TY must be the same. So this is also 8.6. Yeah. So now I'm going on to B. It says find X. So let's go look at this again. I'm looking at OY, right? OS, and this is being bisected by TD, and we know that this line TD is perpendicular and it cuts OS in two. So this is a perpendicular bisector. That means your sides of 46 right here and 3x plus 10, they must be congruent, or their values are equal, measurements are equal. Okay. So what we're going to do is we're going to say that 46 is equal to 3x plus 10. Make a better 10. Okay. So now we need to solve for x. So let's put my line down the middle. I have x is only on one side, so I'm going to get rid of this 10, and I'm going to get rid of this 10, minus 10 minus 10, so 3x is equal to 36. Okay, then I'm going to divide by 3, and I will say that x is equal to 12. Now let's go on to example 2C. Now we see that again, this is my bisector, and I know that because TP is Oh, actually, let me go back and say that this right here, we know that TS and SP are congruent. That means this point right here, or at S, is equidistant to T and to P. That means that this point S must be on a perpendicular bisector, which means then that TO right here and OP must be congruent, because again, this is a perpendicular right there bisector, cuts the TP in half. So let me clear this up so you can see it better. And let's write the equation. We know that 6x minus 4 must be equal to 4x plus 4. Okay, so let's write my line down the middle. I like to move my small x over to my big X right here. So that's gone. This is 2x minus 4 and plus 4. They're still equal. Now I have this minus 4 with the 2x, and I don't want it there. I want it on the other side. So I will move it there. So 2x is equal to 8, which means divide by 2, x equals 4. Oh, x equals 4. That is not what we're looking for. We're looking for TP. So TP is from T to P. It's all of this right here. So if I just solve for half of it, let's say if I just solve for T to O, I can just double it. So now I have 6 times x, which is 4, and I will minus 4. So this is 24 minus 4 is 20, right? So that means this is 20. That means this is also 20. So TP is equal to 40. Right? So this again is TO only. Now let's go over here. So we are going to find the perpendicular bisector. Perpendicular is our key word here, of the segment with the given endpoints. A 6 and negative 3. Let's go look for that. 6, negative 3 is right here. And 0, 5 is here. X is 0, y is 5. So this is my segment from here to here. And I know I need a bisector. So I know it goes through the middle. So we will find the midpoint. So what's the midpoint of AB? Well, it's the middle of the axis and the middle of the O's, right? So my middle of my axis is going to be 6 and 0. I need to add my 6 and my 0 divided by 2. That's going to be 3. Then I'm going to go over here to my y. So my midpoint of my y is, what's my y's? My y's are negative 3 and 5. So I'm going to add my negative 3 and 5, and I'm going to divide by 2. Negative 3 plus 5 is 2. 2 over 2 is 1. So this is 1. So my midpoint really is x is 3, y is 1. Okay. So that is my midpoint. So x is 3, y is 1. My line could be better, but that's where it is. So I know my bisector will go through here. Now I need the slope of AB because I need to find the slope of the perpendicular line going through AB. So let's see, if my slope here, oh, I gotta find slope. Let's find slope. Slope is small m. Now let's write this. Again, let's do my y's first. I can do negative 3 minus 5, and then I'll do my 6 minus 0. So this is going to be equal to negative 8 over 6. And you can simplify this into, let's see, 4/3. It's negative 4/3. So now I need the line perpendicular to AB, which means I need to flip and change the sign, negative reciprocal. So my new slope is going to be 3 over 4, and this time it's positive. So find another point on the perpendicular bisector. So I am going to use my slope of 3 going up. 3 goes up, 4 goes to the right. So I'm going to go up 3. 1, 2, 3, and I'm going to go right 4. 1, 2, 3, 4. That is my point right there. So this is my new line right here. Okay. So now, what is my new point? Actually, I can just read it off my graph. So x is 7 and y is 4. So I will write 7, 4. All right, next one. So if WO is an angle bisector, so not bi, is an angle bisector of triangle WRT, what can you conclude about the angles? So I guess there was a triangle here, but let's draw WO. Right, so WO is here, so O is somewhere here. Not sure where, but let's say somewhere here. So what can we conclude? Well, since it's an angle bisector, or W is an angle bisector, then I know that these two angles must be the same, right? So RWO, or angle RWO, must be congruent to angle OWT. Angles are the same. So what is an angle bisector? Angle bisector theorem. So if a point is on the angle bisector, now I should actually write it out, angle bisector of an angle, then the point, the point is equal distance to both sides of an angle, of an angle. Okay, what does that mean? So if I have a point on my angle bisector, remember this red line is my angle bisector. Let's say I chose O. That means that the distance from the point to the angle, the side of the angle, is the same as the distance on the other side from the point to the side. And remember, the closest distance between a point and a line is a perpendicular line. So those distances right here are congruent. Now the converse is obviously you switch P and Q. So this time you're going to say if a point is equidistant to the point of an angle, then the point is on the angle bisector. So if a point is equal distance to both sides of an angle. Both sides of an angle, then the point is, then the point is on the angle bisector. On the angle bisector. So again, all it's saying is that, well, if you have a point, you don't know if it's angle bisector, but you know that it is equal distance from, again, let me highlight. All you know is that this point right here, point O, is equal distant to your sides of your angle. Okay. Then that means the point O must be on your angle bisector. So let's go apply these. So now we have, let's see, okay, so notice here we have line E. I don't have a point here, ELV, I don't know, let's call this O. Okay, let's call that O. So I know EO is perpendicular first of all. So I know this is perpendicular, okay? So if EO is a perpendicular bisector, that means that these two angles must be, these two segments must be the same. So if that's 18, this should be 18. And if one side is 24, right? So the distance from E to V from the point on your angle bisector to V right here, if this is 24 right here, this also has to be 24. Okay. So EL equals 24. Now let's go look at this right here. So find the measure of each. If we notice, let's see, look at point T, and point T right here has a distance from point T to the side of the angle is 9, and it has the same distance here, that's also 9. That means point T must be on an angle bisector, right? So HT right here is an angle bisector, right? That means both of your angles right here must be the same. They're congruent. Okay. So I'm going to, let's equate them. Let's see. I know that 2x plus 12 is equal to 5x. Okay. So 2x plus 12, again, remember this is angle AHT. This is angle AHT. And let's see, 5x degrees, that's EHT. EHT. Angle EHT. These two are congruent. Right? So I can say that those two angles are, the measures are the same. So if I solve for this right here, let's put a middle. I have an x here, and I have an x here, so I need x's on one side. So I'm going to move this smaller x over here. I'm going to cross that out. This becomes 3x right here. This becomes 12 still. So let me bring it over here. 12 equals 3x. Divide by 3, divide by 3. X is equal to 4. Okay? So I know x equals 4, but remember, I'm looking for AHT. that is going to be this right here. So AHT is 2x plus 12, right? And I know that x is 4, so this becomes 2 times 4 plus 12. That's 8 plus 12. This is equal to 20 degrees. Okay. Now let's look at AHE. Where is that? AHE. A is here. Use L. A, L. AHE. That's the big triangle. Okay. So AHE is equal to, well, it's the sum of these two angles, right? So if I know that this is 20, this also must be 20. Okay. So my total angle size is 40 degrees. All right, this is the total. All right, now I'm looking for ATH. Where's ATH? A is here. Let's go highlight it. I'll use brown. Hold on. Brown right here. ATH. A is here. T is here. H is here. Okay. How do I find this? So I know that my angles inside of a triangle add up to 180. So I know that one of the angles is 20 degrees. Oops, let me use a pen. So one of my angles is 20 degrees. And my other angle is, well, it's that 90 degrees right here. So 90 plus angle ATH, which let's just call it, well, let's just add these two first. Let's do that. Okay, 90 plus 20 is equal to 110, okay? Equals 110 degrees, okay? So if I subtract that from 180, so 180 minus 110, I get 0. 8 minus 1 is 70. This must be 70 degrees then. That's 70 inside here. So this is equal to 70 degrees. Okay. So let me box this. Let's box this and box this.